Imagine buying a brand new car, and just a few years later, the engine starts burning oil. Timing chains stretch, turbos fail, sensors die, and repairs cost more than the car is worth. Meanwhile, your grandfather's old Toyota or Mercedes is still running perfectly after 300,000 miles. So here's the big question. Why do modern engines fail so quickly, while older engines seemed bulletproof? Today, we're breaking down the shocking truth behind why modern engines, despite being more powerful and more advanced, simply don't last like they used to. Stay until the end, because the final reason is something manufacturers never want you to hear. Modern engines are faster and more efficient, but they're also far more fragile. A small 2-liter engine today produces the same power as a V8 used to produce. But that power comes at a cost. Higher power creates higher stress, and higher stress always reduces engine lifespan. Older engines were understressed. Modern engines are pushed to the limit every single day. One of the biggest reasons modern engines wear out faster is turbocharging. Just a few decades ago, most cars were naturally aspirated. Today, almost every car uses a turbo to get more power and better fuel economy. But turbos add extreme heat, extra pressure, faster oil degradation, and more parts that can fail. A turbo spins up to 200,000 revolutions per minute. That's an insane amount of mechanical stress. And when a turbo fails, the engine often fails with it. Older engines simply didn't have to deal with this level of strain. Another major reason modern engines suffer is the use of extremely thin oils like OW20 and even OW16. These oils reduce friction and improve fuel economy, but they also reduce protection. Thin oil breaks down faster, handles heat worse, and forms a much weaker protective film between metal components. Older engines used thicker oils like 10W40 that offered much stronger protection, especially under heavy loads or long-term use. Then there's direct injection, a technology that made modern engines more powerful and more fuel efficient. But direct injection comes with a huge downside: carbon buildup. In older engines, fuel washed over the valves and kept them clean. In modern engines, the valves never get cleaned. Carbon builds up quickly, leading to misfires, rough idle, power loss, and even engine failure. Some engines need walnut blasting at just 40 to 60,000 miles. Older engines never needed that kind of maintenance. Modern engines also rely heavily on sensors and electronics. Oxygen sensors, NOx sensors, high-pressure fuel pumps, variable valve timing actuators, eco start-stop systems, and dozens more components all have to work perfectly. When one fails, the engine can lose power, run poorly, or go into limp mode. And if the wrong sensor fails, it can even cause catastrophic engine damage. Older engines had far fewer failure points, which made them simpler and much more reliable. Start-stop systems are another hidden engine killer. Every time your engine shuts off at a traffic light and restarts a few seconds later, that creates wear. Modern engines, starters, and batteries aren't built to handle tens of thousands of extra start cycles. Over time, start-stop systems increase wear on bearings, starters, camshafts, timing systems, and more. Manufacturers claim it saves fuel, but the long-term cost is much higher. Another factor is weight reduction. Older engines used heavy materials like cast iron and thick steel, which lasted forever. Modern engines use lightweight aluminum blocks, thin cylinder walls, and smaller internal components. This reduces weight and improves efficiency, but also reduces durability. Lightweight parts wear faster and have a shorter lifespan by design. But here's the darkest truth of all. Modern engines are not built to last 30 years. They're built to last just long enough to get past the warranty period. After that, automakers expect you to buy a new car. Planned obsolescence is real. Old engines were over-engineered because manufacturers cared about reputation. Today, most engines are under-engineered because manufacturers care about sales. A car that lasts forever is bad for business. But not all modern engines are bad. Some brands still build engines with long-term durability in mind. Toyota's dynamic force engines, Lexus V6 engines, Honda's naturally aspirated engines, Mazda's Skyactiv engines, and Mercedes-AMG hand-built engines can last an extremely long time when maintained properly. So, reliability is still possible, it's just no longer the priority for most companies. So why do modern engines fail faster? Because they chase power, efficiency, emissions, and cost reduction at the expense of durability. Old engines were simple, strong, and slow. Modern engines are fast, efficient, and fragile. That's the trade-off you get with today's technology. If you enjoyed this breakdown, hit that like button because it really helps the channel grow. This is Drive Edge, where we reveal the hidden engineering behind the cars we drive. Now tell me in the comments, do you think modern engines are worse, or are they just more advanced? And which engine do you trust the most? Thanks for watching, and drive safe.